Download this code from codegive.com, link in the description below. OK, let's dive into dealing with range restriction in SPSS. This is a critical issue when analyzing data, especially in areas like employee selection, test validation, and survey research. This tutorial will cover what range restriction is, why it matters, how to detect it, and the primary methods for correcting for it using SPSS. We'll also include detailed code examples and explanations. Understanding range restriction. What is range restriction? Range restriction occurs when the observed range of values on a variable is smaller than the full range of possible values in the population of interest. Essentially, a portion of the distribution is missing or underrepresented in your sample. This truncated sample leads to skewed or inaccurate statistical relationships. Example Imagine you're studying the relationship between pre-employment aptitude test scores and job performance. If you only have data on the employees who were hired, i.e., those who scored above a certain cutoff on the aptitude test, your sample is restricted. You lack information on individuals who scored lower and were not hired. This restriction affects your ability to accurately estimate the true correlation between the aptitude test and job performance. Why does it matter? Range restriction has several significant consequences. Underestimation of correlations. The most common problem is that range restriction attenuates, reduces, the observed correlation between two variables. You'll find a weaker relationship in your restricted sample than what exists in the unrestricted population. Inaccurate regression coefficients. Regression models based on restricted data will yield biased coefficients, potentially leading to incorrect inferences about the predictors of an outcome. Invalidity of selection procedures. In personnel selection, range restriction can undermine the validity of selection tests. If you underestimate the correlation between a test and job performance, you may mistakenly discard a valid selection tool. Misleading conclusions. Ultimately, range restriction can lead to incorrect conclusions about the relationships between variables, impacting decisions based on the analysis. Types of range restriction. Direct/explicit restriction. A specific cutoff score or selection criterion is applied directly to a variable, limiting the observed range. Example: hiring only applicants who score above 70 on an exam. Indirect/incidental restriction. Restriction occurs on one variable indirectly because of its relationship with another directly restricted variable. Example: restriction on job performance because high test scores, which are correlated with job performance, are used for hiring decisions. Truncation. The range is cut off at a single point, eliminating values below or above that point. Selection. Cases are not randomly selected, they are chosen based on criteria that lead to a non-representative sample. 2. Detecting range restriction. Detecting range restriction isn't always straightforward, but here are several clues to look for. Theoretical considerations. Think about the data generating process. Are there any selection procedures or criteria that might systematically exclude certain individuals or values? Example: minimum GPA requirement for graduate school admission. Descriptive statistics. Reduced variance/standard deviation. Range restriction leads to a lower variance and standard deviation on the restricted variable compared to what you'd expect in the unrestricted population. Compare your sample's standard deviation to population norms or previous studies, if available. Skewness and kurtosis. Range restriction can introduce skewness, asymmetry, and kurtosis, peakedness or flatness, to the distribution of the restricted variable. Asterisk scatter plots. Asterisk visually inspect scatter plots of the variables of interest. If you suspect range restriction, look for a truncated or chopped off appearance, where data points are missing from one part of the plot. This is especially useful for examining the relationship between the restricted variable and another variable. Asterisk knowledge of selection procedures. Asterisk if you know the selection ratio, the proportion of applicants who are selected, this provides crucial information for applying correction formulas. Asterisk literature review. Asterisk consult previous research in your area. Have other researchers encountered range restriction with similar variables or populations? 3. Correction methods. The primary methods for correcting for range restriction involve statistical adjustments to estimate the unrestricted correlation. We'll focus on the most commonly used techniques. Asterisk Thorndike's case 2 correction, direct range restriction on the predictor. Asterisk assumptions. Asterisk linearity, homoscedasticity, equal variance of errors, normality of residuals, and direct restriction on the predictor, the variable used for selection. Asterisk formula. Asterisk R sub xy slash sub equals R sub xy slash sub asterisk S sub x slash sub slash S sub x slash sub slash sqrt1 R sub 2 slash sub xy slash sub plus R sub 2 slash sub xy slash sub asterisk S sub 2 slash sub x slash S sub 2 slash sub x slash sub, where asterisk R sub xy slash sub is the estimated unrestricted correlation between x and y. Asterisk R sub xy slash sub is the observed, restricted, correlation between x and y. Asterisk S sub x slash sub is the standard deviation of x in the unrestricted population. Asterisk S sub x slash sub is the standard deviation of x in the restricted sample. Asterisk Thorndike's case 3 correction, indirect range restriction on the predictor. Asterisk assumptions. Asterisk linearity, homoscedasticity, normality of residuals, indirect range restriction on the predictor, and a known variable that is not restricted, example applicant pool scores. Asterisk formula. Asterisk R sub xy slash sub equals R sub xy slash sub asterisk U sub x slash sub U sub x slash sub slash sqrt1 R sub 2 slash sub xy slash sub plus R sub 2 slash sub xy slash sub asterisk U sub 2 slash sub x slash U sub 2 slash sub x slash sub, where asterisk R sub xy slash sub is the estimated unrestricted correlation between x and y. Asterisk R sub xy slash sub is the observed, restricted, correlation between x and y. Asterisk U sub x slash sub is the standard deviation of x in the unrestricted population. It is calculated by U equals S slash sqrt, 1, R sub 2 slash sub xz slash sub. Asterisk U sub x slash sub is the standard deviation of x in the restricted sample. It is calculated by U equals S slash sqrt, 1, R sub 2 slash sub xz slash sub. Asterisk S sub x slash sub is the standard deviation of x in the unrestricted population. Asterisk S sub x slash sub is the standard deviation of x in the restricted sample. Asterisk R sub xz slash sub is the correlation between x and z, unrestricted variable. Asterisk R sub xz slash sub is the correlation between x and z, restricted variable. 4. SPSS implementation and code examples. Let's create an SPSS dataset and apply the correction formulas. Explanation asterisk. 1. Data creation asterisk. We create a simple dataset with aptitude and job performance scores. In a real-world scenario, this would be your actual dataset. The data provided is already restricted because we're assuming it represents only those who were hired. 2. Descriptive statistics. Descriptives is used to calculate the mean and standard deviation of the variables in the restricted sample. The key value here is the standard deviation of aptitude. 3. Observed correlation. Correlations calculates the correlation between aptitude and job performance in the restricted sample. This is the RxY value that goes into the correction formulas. 4. Manual calculation, or external script. Crucially, SPSS does not have built-in functions for Thorndike's corrections. You must perform the calculations manually using the formulas provided or by writing a small program, example in Python, R, or using SPSS's scripting capabilities, to plug in the values. 5. Indirect range restriction implementation. Create an unrestricted variable. Unrestricted is created to simulate scores of the applicant pool. Correlation analysis. Correlations is used to find the correlations used in the equations. 6. Apply the formulas. Using the standard deviations and correlations calculated from SPSS, manually calculate the corrected, unrestricted, correlation using the appropriate Thorndike formula. Example calculation, Thorndike case 2, direct restriction. Let's say R sub xy sub, observed correlation, equals 0.40. S sub x sub, unrestricted SD of aptitude, equals 15. S sub x sub, restricted SD of aptitude, equals 8. Plugging into the Thorndike case 2 formula. R sub xy sub equals 0.40 15/8 sqrt1 0.40 sub 2 sub plus 0.40 sub 2 sub asterisk 15 sub 2 sub 8 sub 2 sub. R sub xy sub equals 0.75 sqrt1 to 0.16 plus 0.16 asterisk 225/64. R sub xy sub equals 0.75 sqrt 0.84 plus 0.16 asterisk 3.515625. R sub xy sub equals 0.75 sqrt 0.84 plus 0.5625. R sub xy sub equals 0.75 sqrt 1.4025. R sub xy sub equals 0.75 1.184. R sub xy sub 0.63. The corrected correlation, 0.63, is significantly higher than the observed correlation, 0.40, demonstrating the impact of range restriction. V. Important considerations and cautions. Assumptions are critical. The accuracy of the corrections depends heavily on the validity of the assumptions. Violation of linearity, homoscedasticity, or normality can lead to inaccurate results. Always check these assumptions using residual plots and other diagnostic techniques. External standard deviation. The most challenging aspect is often obtaining a reliable estimate of the standard deviation in the unrestricted population. Use data from previous studies, applicant pools, or theoretical considerations. If the unrestricted SD is substantially different from the true SD, the result will be skewed. Direct versus indirect restriction. Choosing the correct formula, case 2 or case 3, is essential. Incorrect application will yield biased results. Carefully consider the selection process and whether the restriction is direct or indirect. Multiple corrections. If you have multiple range restriction issues, example restriction on both the predictor and criterion, the correction process becomes more complex and may require more advanced statistical techniques. Asterisk alternatives to correction asterisk in some cases, it might be better to avoid range restriction correction altogether. If the assumptions are severely violated or if you lack reliable information about the unrestricted population, it's better to acknowledge the limitation in your analysis. Consider alternative statistical methods that are less sensitive to range restriction, such as non-parametric correlation. Asterisk reporting transparency asterisk always clearly report that you have corrected for range restriction, the method you used, Thorndike case 2 or 3, and the values used in the correction, example the unrestricted standard deviation. This allows readers to evaluate the credibility of your results. 6. Advanced techniques, beyond the scope of this tutorial but worth knowing. Asterisk 2-stage least squares, 2SLS used to address endogeneity problems, where the predictor is correlated with the error term, which can be exacerbated by range restriction. This is a more complex technique. Asterisk maximum likelihood estimation, MLE can be used to estimate parameters in the presence of truncated or censored data. This requires specialized software and statistical expertise. Asterisk Bayesian methods asterisk Bayesian approaches can incorporate prior information about the unrestricted distribution, improving the accuracy of estimates. 7. Conclusion. Range restriction is a common challenge in many research areas. Recognizing it, understanding its consequences, and applying appropriate correction methods are crucial for obtaining accurate and valid statistical inferences. While SPSS does not directly compute the formulas, it provides the necessary tools to calculate descriptive statistics and correlations, which are essential inputs for the correction. Remember to carefully consider the assumptions of the correction methods and to transparently report your procedures.